Let's look at polynomial inequalities. For example, let's solve the following inequality for x, and then we'll write our answer in interval notation. The first thing we'll do is bring both the 4x and the 20 to the left-hand side of this inequality, which gives us x cubed plus 5x squared minus 4x minus 20 is greater than or equal to 0. Now let's let f of x equal this left-hand side. That is, we're going to let f of x equal x cubed plus 5x squared minus 4x minus 20. Now, in order to solve this inequality, we need to find the x values for which f of x is greater than or equal to 0. But isn't f just a polynomial? So we'll use the fact that a polynomial only changes sign at its real zeros. That is, a polynomial is always either positive or negative in between two consecutive real zeros, which means we need to find the real zeros of f. And we can do so by factoring. That is, we have f of x is equal to x cubed plus 5x squared minus 4x minus 20. And we can factor f by grouping. That is, we can group these first two terms together. They have an x squared in common, which we can factor out, and we'd be left with x plus 5. And then we can group these last two terms together and factor out a negative 4, and we'll also be left with x plus 5. And now we can factor the x plus 5 out of both of these terms. And we're left with x squared minus 4. Which is the difference of two squares, isn't it? Which would factor into x plus 2 times x minus 2. Therefore, f of x will equal 0 when x is equal to negative 5, negative 2, or 2. And these real zeros will partition the real number line into 4 intervals. So let's say this is negative 5, this is negative 2, and this is positive 2. So what we need to do now is choose a value from each of these 4 intervals and determine whether f is positive or negative on each of these intervals. And then we'll choose the intervals on which f is positive. So in this first interval here, we could choose x equal to negative 6, for example. And if we plug x equal to negative 6 into this factored form of f, we can determine the sign of f quite easily. Because if we plug negative 6 in, what do we have? Negative 6 plus 5, which is a negative number, times negative 6 plus 2, which is also a negative number, and then negative 6 minus 2 is also a negative number. And negative times negative times negative is negative. Which means in this first interval here, f is negative. Well, what about the second interval here? We can choose x equal to negative 3, for example. And when we plug this into the factored form of f, we have negative 3 plus 5, which is a positive number, times negative 3 plus 2, which is a negative number, and then times negative 3 minus 2, which is also a negative number. And positive times negative is positive. which means f is positive in this second interval. Now what about this third interval here? We can choose x equal to 0, for example, and plugging this value into this factored form of f, we get 0 plus 5, which is a positive number, times 0 plus 2, which is also a positive number, times 0 minus 2, which is a negative number. And positive times negative is negative. Which means f is negative then in this third interval. And finally, what about this last interval here? We can choose x equal to 3, for example, and plugging this into this factored form, we have 3 plus 5, which is a positive number, times 3 plus 2, which is also positive, times 3 minus 2, which is also positive. And positive times positive is positive. Therefore, f is positive in this last interval. Now remember, we want to find the x values for which f of x is greater than or equal to 0. And we just found that f is greater than 0 in this interval, as well as this interval. But remember, we also have this condition of equality here, which means we need to include the values that make f equal to 0 in our solution as well. Namely, we need to include -5, -2, and +2. Our answer then is close bracket at -5 because we want to include -5, up to -2, again close bracket because we want to include -2, union, close bracket at 2 because we want to include 2, up to infinity. Now it should be pointed out up here that this alternating behavior, minus plus, does not always hold when we're solving these types of polynomial inequalities. For example, if we were working, say, with the polynomial g of x is equal to x minus 1 squared times x plus 3, this alternating behavior would not occur between its consecutive real zeros. And you should verify that to yourself. Okay, this is how we solve polynomial inequalities. Thank you, and we'll see you next time.